Hello, hi. This is Murtuza Ali from Counterpoint Research, and I'm here at CES 2026. I'm here at the Aptiv booth, and I have a special guest today, Dr. Gabor, who is Global Business Development Head for Advanced Safety. And we are here to explore some of the exciting innovation Aptiv has in the advanced safety space, including end-to-end platform for advanced safety, as well as a number of innovation on sensors as well. So, Peter, to kick it off, why don't you explain to us the rationale behind the end-to-end stack that you have and how that helps OEMs autonomy as well as advanced safety?
Yeah. Thank you so much. Thanks for being here with me and with us. Yeah, sure. Aptiv is leading the space of advanced safety driver assistance. Actually, we're the first ones to introduce cruise control in vehicles back in 1999. So we do have a little bit of experience here. And of course, we evolved over the years with multiple generation and platforms. Right now, we are at our 6th generation ADAS platform, which uses machine learning based technology for the data processing. But we also get into the behavioral models, like how the car should behave, right? That's where we actually train the entire vehicle from the sensorial inputs down to the actuators to behave like a human driver. That's why we call it end-to-end, right? It goes from the sensor inputs down to the behavioral model and also the actuators in the vehicle. And the main advantage is that our customers, the OEMs, but even the final drivers, feel a more humanistic behavior of the features that gives a higher quality of service and also an expanded operational domain. Means those strange situations where the vehicle might potentially react in a weird way can be covered easily because the algorithms react actually as a human being. That basically in a nutshell. I would invite maybe we can have a look at the holistic portfolio here.
Indeed, yeah.
Yeah, so we have the vehicle and the pavilion. This is representative of the cars that are basically running outside on the streets. We have demonstrators that are point-to-point urban hands-free navigation. It's something that we're demonstrating on the streets of Las Vegas here live. The car can be scanned by the help of this slider. I can actually move the slider and showcase the content basically of the vehicle. We have a very comprehensive portfolio with a lot of content. For the sake of time and for the interest, we'll actually zoom into the advanced safety domain as we were just discussing, right? You immediately recognize we have sensorial content, the sensors, we have corner radars, front radars, we have cameras, the interior cameras as well as the exterior cameras, and of course compute and the underlying software stack. All this content can be also seen here on this other screen. I'll invite you now to have a look with me here on the driving stack. Yeah. So first of all, briefly, I have to say that there is a trend on the market of merging driving and parking into one single domain, right? These are two historical separate domains. They are coming together because we're talking about slow speed automation here, and this is a classical driver assistance. We're doing this by merging the hardware and the software together to reduce complexity and cost and also improve the overall performance of the systems. Let's have a look at the stack. As we were discussing, this is a typical end-to-end AI architecture that we're using. Sensorial input here from the left, getting into the perception, fusion, and behavioral planning software components. This entire stack is basically trained at once. That's why end-to-end. However, we do have interconnecting points that allow a very important safety guardrail to control these intermediate computing steps. By doing that, it can guarantee the functional safety requirements for the features to act as we wish. It's a little bit like you would have a driver here and a co-pilot checking on the driver what the driver is doing, right? And actually allowing those actions to be taken or not. So this is up and running on the demo vehicles outside and is fed by state-of-the-art sensors that I would like to illustrate to you. So first of all, we're introducing for the first time our Generation 8 radars. What I'm holding in my hand is a corner radar, very compact in size. It's powered by Aptiv's proprietary chipset. That means we developed our own silicon for radars and the processor as well. And this has been, a certain invest. It started several years back. We had the vision of implementing our own IP onto silicon to create a unique product that, unlike the competitors, can solve the problems of our customers. This device feeds the information to our end-to-end AI stack and creates a very rich representation of the environment, helping the customers to solve those critical use cases, right? And this is exactly what the auto industry is searching for. You need reliable systems that work also in multiple different conditions, right? So,
Silicon gives you a significant advantage in terms of the control you have,
absolutely,
as well as the cost, right?
totally.
And I think, is that okay to open it?
Yeah, it's not okay to open it with just, it's a very complicated part, but just I want to show, obviously, we're leveraging our proprietary 3D air waveguide antenna technology, fully developed in-house, is something that we're very proud of. We decided to invest in that as well. That helps us to create a solution that the competition is not able to mimic.
Yeah.
And coupled with our proprietary chip, allows us to create a very cost-effective solution, as you say, but also to focus on hosting those IP elements that are essential to create good performing products. So that's not an off-the-shelf solution. You understand? Important. We do have a corner radar version as well as a front radar version. And in this moment, I'd like to show how. So you can see here is a vehicle in the middle of the screen, right? Hosting 5 of these sensors, 4 corner radars and 1 front radar, driving in a city. In a city, we did some recording just before Christmas. This is the raw, unfiltered point cloud. We see that we have a full 3D perception of the environment. The tunnel is perfectly accurately depicted. We see the cars. There is right now no tracker. We're just showcasing the raw data for your eyes as an observer. Zooming out, you see that we paint the entire surrounding in 3D. We did have a color coding illustrating the elevation, the height of objects. Bridges are in purple. You see that the bridges are actually correctly identified as underdrivable. This is really important because all of a sudden we're adding a completely new dimension. And it helps you to solve those critical use cases for the features, right? You have probably seen similar pictures in the past. They were very much given from high-end LiDARs with exorbitant costs, right? Also very noisy rotating LiDARs, of course. Today, those systems are very exotic and expensive. Well, we can deliver this kind of performance with extremely cost-effective radars, which are built into the bodywork of the vehicle. They are not even visible, right? It's a state-of-the-art modern radar technology, which we're applying to our end-to-end machine learning-based stack. You see the shape of the houses is sketched up. So it's really impressive performance with, as I said, mass production ready, very cost-effective. And we have already a first customer award. These are hitting the market in Q3 2027.
Oh, that's quite good.
Yes, and we're proud of that.
Obviously, the whole control on the silicon allows you to speed up that process.
Correct. It's over so fast. Yeah. I would like to pivot to a second topic.
Yeah.
Which is also sensors. It's innovation. What I'm holding in my hand is a surround view camera, like the ones that you used to see in vehicles. However, around the lens, there is a miniaturized nano radar embedded in the same housing. Wow. So this is a really tiny package, 32 by 32 millimeters. I'm holding an A sample in my hand. The final shape and form will be slightly more, round shaped and smaller. So this device is giving through the classical cable that you're used to. Like in surround view cameras, there's one cable coming out, right? Yep. Through that same cable, we're also sending raw level data from the radar portion of the device. It's transmitting through one single bus of the picture as well as the radar information. But why are we doing that? Because a camera doesn't give you a depth information, right? The algorithms would try to estimate a depth picture, but we're introducing native distance measurement means a radar that helps to recreate the environment in a way more accurate manner, right? And also
close to the ground truth, right?
Exactly. It's basically closer to the ground truth. It helps me to solve critical use cases in parking scenarios. And through the fusion between the radar and camera, I can recreate the environment very, very accurate. Now, we have been introducing those systems on the car here. You can have a look at the preliminary integration that we have done in the side view mirrors, as well as in the front and the back. These systems are currently the engineering design units, which are slightly larger than the final product. What I'm holding in my hands is more compact than what you see in the car. Those sensors are able to scan the environment around the vehicle and create a gapless, seamless 360-degree coverage around the vehicle, both with a picture as well as with radar, right? So what happens next is all of a sudden, you do not need your ultrasonic sensors for parking. Reason is because you're covering the zone in the front. In the corner, you have the corner radars, and all of a sudden, those sensors can be taken off the car. And obviously, this is something that our customers love because designers are excited.
Yeah.
Finally, sleek, smooth bumpers. And not only that, but performance is also superior.
And the unreliability remote of the ultrasonic sensors, they always go off in your car.
Exactly. And just think about the hassle that you have for the color matching. If you order a black card, this black sensor, the red water letters, it's in all of these bezels that you have to match, right? So it's a huge effort actually to introduce them. Last but not least, performance. Of course, you might know that radar measures angle natively. That means it can actually measure the height of a curbstone, or if it's a wall, or if it's a box, right? And ultrasonic sensors cannot do that. That means we're actually able to reconstruct complex scenarios better, introducing new features. What about, for instance, the door opening warning feature? If a curbstone is too high, the feature would warn you not to smash the door against the curbstone.
Wow.
Wow.
I mean, that has actually happened with me
You see?
on a new car.
Yeah.
Wasn't me, my child, but it annoys you nevertheless. And then also the joy alloy curving as well.
Yes, correct.
Prominent with.
Absolutely. So, and that's exactly those are the features that the customer are excited about because you're introducing this basically at a cost neutral, right? So we're not adding cost. We're actually taking content away. And of course, the sensors per se is more expensive than a camera only. But all in all, at the vehicle systems level is cost neutral or even less. That helps really the customer to tackle, especially today, right? There's a lot of scrutiny on content in the vehicle. And that's what we're doing, helping our customers to declutter the vehicles, make them sleek, and also improve the overall performance. Well, in a nutshell, that was about the innovation. We got the stack, we got the sensors, radars, the combination of both. I just want to give a last hint. It's not only about the automotive industry. This sensor is attracting right now the attention of the robotics industry. Behind us, we have two industrial robots. This is an industrial robotic shell that's meant to transport boxes in a warehouse. And you can see here, this is a quick 4 sensor, right? So the shell navigates in an environment, of course, a machine learning based perception, by leveraging a picture and a depth perception map delivered by the radar. And here, just behind us, we can see the actual perception of the device. Of course, it's a preliminary graphical user interface for engineering purposes, but you see that we have the depth perception with radar combined with a map. I just walk into the camera to see me. Combined with the depth perception from the camera, and fusing both, you get an accurate reconstruction in 3D of the environment. This is catching the attention of the robotics industry because it's compact, robust, and as you can see, there is even an automatic forklift here, which is featuring the sensors on the top, helping our customers to solve these challenging use cases in robotics environment.
And it's exciting innovation. I mean, from an automotive perspective, you can already see what it's really you're watching it and really on the roads and making a big difference.
Exactly.
Pushing the autonomy game ahead, right? Or like the fact that you already have some brilliant use cases on the robotics is up to because physical AI is gaining huge momentum.
Absolutely.
As CES, we've seen several of those use cases. There are
robots all over the place, right? Right time with the right products, and that's exactly what we're doing.
Yeah, thank you. That was a brilliant all-around view of both the automotive and physical AI and how Aptiv is pushing boundaries on that.
Thank you so much.
Time.